Good morning, students. Today we are going to read very important question in chemistry, that is using kinetic particle theory to explain changes in states of the matter. So this is very important question. Concentrate yourself. We are going to start. When a solid changes into liquid, that is melting takes place, the points to remember are: on heating a solid, the particles absorb heat energy. Heat energy is converted into kinetic energy. Kinetic energy of the particles increases and particles vibrate faster and faster. At the melting point, particles have gained enough energy to overcome the attractive forces between them. Particles are able to move away from their positions and form a liquid. At the melting point, temperature remains constant because heat energy is used to overcome attractive forces between particles and separate the particles so as to change the solid into a liquid. Energy required to change a solid into a liquid at its melting point is known as latent heat of fusion. Now we are going to read the change from liquid to gas, that is actually boiling. The important points to understand are: on further heating, the kinetic energy of the particles increases even further. The particles move about faster and faster. At the boiling point, particles have gained enough energy to overcome the attractive forces between the particles and break free from one another. The particles are able to escape from the liquid and form a gas. At the boiling point, temperature remains constant because heat energy is used to overcome attractive forces between particles and separate the particles to change liquid into a gas. Energy required to change a liquid into a gas at its boiling point is known as latent heat of vaporization. Next point which we are going to read in the lecture is change from gas to liquid, that is called condensation. The points to understand are: when a gas is cooled, the particles lose heat energy. The kinetic energy of the particles decreases. The particles move about slowly. The attractive forces between the particles are now able to draw the particles closer together. Condensation takes place and the gas changes into a liquid. Next topic which we are going to read in the lecture is the change from liquid to solid, that is called freezing. On further cooling, the kinetic energy of the particles decreases even further. The particles slow down even more. The attractive forces between the particles are now able to stop the particles from moving freely. Freezing takes place and the liquid becomes a solid. And here is our example. Figure below shows a closed vessel containing equal volumes of the water and steam at atmospheric pressure and 100 degrees C. So the question is, in A part, is the number of the water molecules present in the steam and in the water are same? Explain your answer. So answer is, the number of the molecules in steam and water are not equal. The molecules in the steam are distributed very far apart from each other because this is in gaseous state. The molecules in the water are arranged very close together because this is a liquid. Hence, there are less molecules in steam than in water. B part is, what process is taking place in the vessel? So, the answer is boiling. At atmospheric pressure, the boiling point of the water is 100 degrees C. Second question, second part is, why is the amount of the water and steam in the vessel constant at all times? Because vessel is closed one and temperature remains constant at 100 degrees C. So that's why at the boiling point, water and steam are in equilibrium. The rate of the movement of the molecules from the water into the steam and from the steam into the water are equal. C part is, how would you change all the steam into a liquid? So because temperature is constant, that is 100 degrees C, we can change by changing the pressure. So answer is, keeping the pressure constant at atmospheric pressure, cool the steam. Steam will condense into water. So this was the topic. Read it again, make your notes. Thank you so much.